Good morning, good afternoon. My name is Alke Halberg. I am part of the Cohesive Marketing team. I will be assisting the team today with the webinar as moderator. We will give it another 30 to 60 seconds to allow all the attendees to join us on this call. Great, I think we can start. Hi everyone and welcome to our webinar on launching a reliability program in mass. Before we start, I would just like to highlight some administrative tasks. Note that this webinar will be recorded and distributed post-webinar. All the attendees are currently set to listen-only mode, but feel free to post any questions or comments in the chat or question box. We will address these at the end. Should you have any technical questions or problems, please log it with the GoToWebinar technical team in the form of a question mark or help section on the panel itself. Right, I will be handing you over to the host in a bit, but let me do an introduction of our speakers and Cohesive first. Working across all stages of the life cycle, Cohesive helps owner-operators embed digital ways of working that drive operational efficiency and enhance asset performance. Our work is in advisory practices, Maximo, change management, managed services, and E2E offering. We have multiple awards from IBM to Vedantix as well as a Polish Quality Award. Cohesive is also industry leaders for Canadian Maximo User Group, Canadian-based energy client support, a platinum sponsor to the Maximo Working Utility Group, and a board member to the Oil and Gas Maximo User Group. Right, our speakers for today are Dan Hilke, Senior Consultant at Cohesive. He is technically sophisticated and a business-savvy international maintenance management professional with a 30-year career reflecting strong leadership qualifications. His experience spans onto multiple industry sectors such as transportation, utilities, oil and gas, mining, pulp and paper manufacturing, and aerospace. Then our next speaker is Patrick Connerty, Director of Asset Management Services at Cohesive. He is an accomplished IT professional with 2 decades of experience supporting organizations in a wide range of sectors to implement their enterprise asset management and asset lifecycle solutions. These include utilities, manufacturing, and facilities management. He oversees Cohesive's Mass Center of Excellence, which includes best practice development, internal environments, and enablement. So without further ado, let's dive in and hand over to our first speaker for today, Patrick.
Thanks, Elga. I'll be kicking off with our agenda and what we hope our attendees take away from today's session. Beginning with the value of doing the right maintenance at the right time on the right equipment. I'll explain that. Understanding the different types of asset failures and their causes. Exploring a couple of different maintenance strategies. What do you need to know about those? And how can you launch a new reliability or maintenance initiative within your business? Also, talking about the reliability strategies library that IBM released. How can that be used as an accelerator with launching your initiative? And then coming through to key takeaways. What are some of the common pitfalls and things you need to know? And then next steps. Okay, let's get into doing the right work. I'm going to be setting up a foundation of understanding for today's session, and that starts with the value of doing the right maintenance. If we talk about a water pump that was designed to pump 400 gallons a minute, we know that factors like environmental conditions, improper maintenance, can impact the overall performance over time. And that's why improving the availability, functional performance, and asset life are critical. Cohesive is seeing improvements of overall availability in our programs up to 30%. So let's understand how these concepts can apply to that pump. Within the availability box here, if we look at that pump within a municipal water system that supplies critical operations, if it fails, that's going to disrupt supply it could impact downtime, inefficiencies, and have compliance implications. By implementing a reliability initiative, you can reduce the unplanned downtime and increase availability. And Dan's going to talk about how you can tackle that in later slides. Looking at lengthening the equipment uptime isn't just about whether the pump is running or not. It's understanding, is it running at the right capacity? As I mentioned, our pump should deliver 400 gallons per minute, right? But what if it's down to 300 or 350? We need to start to dig into the how and why and understand what the functional design was set at and what were the key factors there. Understanding implications like, is there sediment buildup in the line? Do we have impeller wear? Is there an issue with the seal? Will help measure beyond whether the asset is just on or off, and we can then improve the overall functional performance over the asset life, which is the last part we're trying to cover here, is extending that, right? Doing the right maintenance at the right time will help maximize the useful life of the pump and delay capital replacement costs, right? Looking at overall total cost of ownership. So the pumps can degrade over time, and why do some last longer than others? We'll also continue to explore that further in the presentation. What do you need to understand about condition-based maintenance and tracking key indicators? So bringing that together, we want to improve availability of our pump or key equipment within that, understanding what the operational context is, optimizing that overall performance and extending the life. So as I had mentioned, right, operational context. We're looking at the environmental, operational, and external conditions that can affect that asset performance and longevity of the asset. So continuing with these key concepts, it's important to understand that the same pump installed in different operating environments will require different maintenance strategies, right? And have different reliability risks due to those consequences of failure. Furthering with our example, if we look at that pump in the setting of coastal Florida versus central Missouri, right? Coastal Florida is going to be hot, humid, and have salty air, and fewer climate change fluctuations, within temperature, where central Missouri will have cold winters that they need to prepare for, right? The corrosion risks are going to be varied between the salination, where that in Missouri, right, might come from underground minerals. So how does that impact the pump? So looking onto functional failure, Dan's going to start to introduce the point at which the asset can no longer deliver its intended function. We've talked about that 400 gallons per minute, and he's going to further expand into the P to F curve. Before we do that, we want to discuss the levels of maintenance maturity or reliability maturity, and I'll turn it over to Dan to walk through those steps.
Okay, so not all companies are on the same path with their reliability program, and we have different levels of maturity that as you do an assessment of where you're at in your business, you can come up with a level of maturity to where you are from a starting perspective, which will allow you to set up your roadmap to build your program to get to that optimized level. So if you think about the initial level of where some companies may be at, it's more of a reactive environment where you're just doing that whole break fix. You're really just, something breaks down, you're sending a technician or a tradesman out there to do that work, get it up and going, and back in business, and then boom, something else goes down, but you're not really tracking anything. If you get into a bit of the repeatable maturity level, that's where you're actually starting to build some sort of a program. You might have a few replacement tasks in where you're starting to change filters, or maybe you're doing some lube tasks on equipment. but nothing's really organized. Nothing's really tracked and so forth. So you may get that done this week, may not do it next week type thing. But as you move up the maturity level, you get into a more of a defined maturity, and that's where you're starting to put some processes and practices in place. You're starting to define the roles. So maybe you now have a planner, you have a scheduler, and you're getting that schedule out. But you're not really tracking any kind of results from that schedule. You're not really adhering to your compliances, and you're still really starting to develop that maintenance reliability program. And then as you move up to the managed, this is where you're actually starting to use your reliability practices. You're starting to have some sort of a strategy for each type of equipment. You may have a criticality assessment done for your equipment. You understand what the criticality is and the risk to the business that this equipment is. And you're starting to track this. So you're looking at KPIs related to schedule compliance or PM efficiencies and so forth. And you're starting to really um, do this on a regular basis. And then when you get to the final maturity level where you're optimized is you're really a well-oiled machine. Everybody knows their role. It's and you're going out there, you're doing that work, you're tracking the compliances, and you're actually making some continual improvements based on those metrics that you're getting. And it's as I said, a well-oiled reliability program. So, with that being said, we'd like to do a poll here today. We'd like to kind of see where everyone sits or where you feel your program is. So, if you could just take a few minutes and um, put your vote in on the poll. Okay, so we'll move on to the next part, and this is where we're going to really get into talking about the different reliability strategy methods and what they are, what kind of return on investment you're going to get, and so forth. So if we talk about reliability centered maintenance, and we're also going to talk about PM optimization, and we're going to talk about maintenance task analysis. So these three strategies, they all are using the RCM methodology, but each strategy provides a different return on investment. There are reliability centered maintenance being the most intense, but also the most resource intensive. And we'll get into that as we go through this the rest of the slides. So we'll just move to the next slide, Patrick.
Okay, are you seeing the RCM slide?
Oh, I am. Sorry. Yep.
Yeah, no worries.
So if we talk about reliability centered maintenance, so what is RCM? RCM is a process to ensure that you continue to maintain your equipment so that it will deliver what you want it to do for as long as possible. So basically, you're minimizing that probability of failure using maintenance plans and being effective in a structured approach. So there are four principles that define that RCM. So if you think about it, the main objective of RCM is to define that primary function and to preserve that primary function. So you're going to identify failure modes that are going to defeat that function, or it's going to prevent that function from occurring. You're also going to prioritize those functions, and which are, you're going to prioritize the failure modes from a risk perspective and how they're going to um, consequence of that failure related to the primary function and the secondary functions. And then you're going to pick effective tasks, which are going to, you're not going to eliminate the failure modes, but what you're going to do is you're going to reduce the risk of the consequence of that failure to the business. And you think about it from a business perspective, not from an asset perspective. So PM optimization and maintenance task analysis, they are both using the RCM principles, but they are not as intense or resource intensive. So for example, PM optimization, you're basically improving the efficiency of your current practice. So you're going in, you're reviewing what you're currently doing, and you're removing the non-value added work so that you are doing the right work at the right time on the right equipment. Maintenance task analysis is where you're actually building that strategy, where you're going to identify the primary function of the system, and then you're going to get into defining the failure modes and the failure effects. But then you're also going to use the decision diagram of the RCM principles to build that program so that you can effectively select the right task to do at the right time. If you think about the overall complexity of an RCM, where you're defining the functions, the functional failures, and working through those failure effects, and then getting into the aspects of going through that decision diagram and understanding what tasks you need to do, this is quicker. You need as many resources to do this, and it's a much quicker way to get a program started and going. A lot of companies start with PM optimization, and then they, depending on the risk of the asset, you may never go to an RCM. You might just do a maintenance task analysis. But if the equipment is in a situation where it's got a high impact on safety or a high impact on environment, you may want to get into that RCM and build your program using that methodology. So let's compare the reliability strategy programs. As I mentioned, PM optimization, not as resource intensive as the other different programs. You really could do this with just one person, whether it's reliability engineer or a maintenance lead. The complexity of the study is fairly low, so you may be just using what the manufacturer manuals, what the manufacturer represents, or something that you've already developed and you're currently doing, and you're just reviewing that and looking at past history and pulling out some of that non-value added work. And really what you're doing here is you're increasing your efficiency. So you're approximately 10 to 15% more efficient on those programs than you would be with the other two programs. If we talk about maintenance task analysis, it's a little more resource intensive. You're going to have more people as part of that analysis. You're going to use your maintenance team who have the experience of the actual failures that they have been doing. You get into using your operations folks, your reliability engineers, and you're going to build that operating context first and understand the boundaries of that analysis. And with that, you're going to be thinking of this as you're not doing anything at the moment. So this is a brand new analysis that you're doing, and even though you still might be doing some sort of a maintenance strategy out there, you do not include that in this program. You're going to build this from scratch, and it's going to become your new program. So when you're finished with this maintenance task analysis, you're going to implement that into the system, where that you're going to remove all of the other tasks and program that you've been currently doing, and this becomes your new maintenance strategy. And you're going to get more efficiency from this, but you're also going to save cost of maintenance because you're really looking at that primary function. You're looking at those failure modes, and you're setting those tasks up to understand which tasks you need to mitigate that consequence to the failure. And then when you get into RCM, you're really it's a much more resource intensive from the resources that you need. So you're going to need people from your maintenance team, your reliability engineering team, your operations team, engineering, safety, quality, finance. You really need to understand the whole aspect of the business when you're putting this together. Um, the complexity of this study is high, so you're going to build that operating context again, but you're also going to get into the primary and the secondary functions of each one of the components within the boundaries and really understand that. You're going to set your risks of each one of the failure modes and the criticality of each one of the failure modes, and you're going to pick that strategy of how you're going to maintain it based on the consequence of that failure and what it has to the business. And this is where you're going to get your highest return on investment. Although you're putting in a lot of resources, you're also going to get your highest return on investment with. I've seen savings up to 20-30% from a cost perspective and also from an efficiency perspective. So you're getting much more availability and reliability out of that equipment. So if we look at, okay, we've talked about the different strategies, but how long does it take to do one? So if I give you a kind of a real world example, this is a pumping system that I'd done a few years back, and this is one that it consisted of 3 pumps and 3 motors and a sump pump, and it was a bunch of different valves and flanges and so forth. And we done an RCM study on this one, so I'll talk to you about that aspect here in a minute. But if we look at from a PM optimization, how long would it take to do that and actually implement that in the system? You're looking at 3 to 5 days from a system of this size. And this is really just, as I mentioned, taking your current what you're currently doing and optimizing that and re-implementing that within the system or modifying within the system. From a maintenance task analysis perspective, you're going to focus on about 30 failure modes an hour to with an experienced facilitator. So this system had 400 to 450 failure modes. So from that perspective, we took about a week to do this, and then it took another week to implement. So usually from the time that you do the study with an experienced facilitator, you're going to do about double it to implement it. So if you do 1 week to do the study, it's going to take about a week to implement it. And it's key that your facilitator and your implementer are at lockstep together when that implementation um, happens, because it's quite difficult for an implementer to interpret what the facilitator was thinking, or what he's writing down, or he or she is writing down, um, when they're doing that analysis. So that's key. Um, but as we done this from a failure mode perspective, or sorry, from an RCM perspective, we had to do some initial training. So the people needed to really understand what RCM was and what their role was as a participant within that RCM analysis. So we actually done some training for a specific group of people. We talked about the RCM concepts. We talked about um, what the goal of this analysis was, and how they could participate, and how we would like them to participate when defining the failure modes and so forth. And as we started, there was a fairly high learning curve. But as we started down that path, we got into the rhythm of defining the failure modes and defining the functions first. Then we get into defining the failure modes. And then as we get into the decision diagram, the quicker that, or the more that you do with that decision diagram related to each one of those failure modes, the quicker this became. But one of the things that of this study that was quite apparent was that, yes, they were in the past, they were doing um, maintenance on this. They were doing weekly rounds, and they would go and they would check and they would see whether there was any leaks, or they were doing vibration analysis and so forth. Uh, but they didn't really take the operating context into place. And you think about, this was in Africa, so during the non-rainy season, everything seemed to be okay. But then in the rainy season, when they get lots of water, get lots of rain, this was in a building that was below ground, and as water would seep in, they had a sump pump that would pump the water out, but they never checked to see if that sump pump would work. So that wasn't part of their task. They would look to see if there was any water in the sump pump pit, but um, when the rains came, and the rains came hard, it actually flooded. And if the sump pump didn't work, it flooded the actual building that they were in. And this did happen. It filled it with 13 feet of water. The sump pump failed because the switch had failed within that sump pump. And it was millions of dollars in damage because they had to replace all the motors. The pumps were needed to be repaired. And this happened twice to them in over a year's time. So just thinking about that sump pump and looking at that sump pump, unless you're doing some sort of a failure finding exercise to ensure that that sump pump actually is running, um, it could bite you. So it's your least inexpensive um, part, but it came to cost you the most amount of money. So that is something um, that was found out when we were doing this study, and we were able to put a task in place to ensure that they did check that on a weekly basis. So let's talk about setting up the right interval to do your maintenance tasks. So if you look at this from a function perspective, you have this piece of equipment, and the pump will continue on this pump scenario, where the initial capacity which is the design capacity of the pump is to pump 500 gallons per minute. But what you want it to do, or what the required capacity is to pump at 400 gallons per minute. So if you look at the initial capacity and the required capacity, you have a gap of 100 gallons per minute. That is your maintenance window. So that is where you actually can go in and do your maintenance on this pump without affecting the functional failure. So the whole idea is that the pump will start to fail and you'll get in there with enough time to plan, schedule, and execute the work before it reaches the required capacity, which is the functional failure. So if we look at the P to F interval, the P is where this pump is starting to fail or is potentially failing. And the whole idea of a PF interval is to do the task at the right time to pick up when that potential failure is happening or starting to occur so that you'll have enough time to do your maintenance work, repair. So plan, schedule, order parts, ensure that you have enough time to execute that work before you actually functionally fail. So for an example, you have that pump that pumps at 400 gallons per minute, but as the system, it pumps it into a tank. So it pumps it into a storage tank, and then when you have another pump that pumps out of that storage tank at 300 gallons per minute. So you're always having 100 gallons per minute ahead. So that storage tank is, say, 90,000 liters. And it takes about 5 hours to pump that storage tank dry. So if you got a pump that you're detecting that the bearing is starting to fail, so say you're doing some sort of vibration analysis on this pump and you're starting to detect that the bearing is failing, it depends on what part of the maintenance window that you're actually picking up that failure. So if you're lower down the curve, you're not going to have the time you need to actually do that repair. So I think if we go to the next slide and we take a look at that, it kind of defines the pieces that are related to making sure you're using the right technology to give you the right amount of time to do that work. So for example, if it takes you 4.5 hours or 5 hours to change that bearing, and it takes 6 hours to completely pump out that tank, if you're using the right technology to identify that failure is occurring, you're going to have enough time then to do that work before it actually gets to the F for functional fail. So if you're using smoke, for example, and you're going there and you're doing daily rounds and you get to the motor and you're actually seeing smoke coming from the bearing, you're not going to have enough time to do anything other than shut it down before it does more damage. But if, on the other hand, if you're doing vibration analysis and you're doing that because the P to F interval is 3 months and 80% of your randoms are 80% of your failures are random, you're actually going to do your vibration analysis every month. And when you detect that, that's going to give you enough time to plan and schedule that work. So that's the whole idea of really understanding that P to F curve and making sure that you're giving yourself enough time to do that, to do that work before you're functionally failed. So if we think about okay, how are we going to execute something like that within um, Maximal? So if we look at it from a perspective of warning, early warning, normal, and alarm, um, we set the PF strategy up by using domains. And so this really helps define that, okay, technician one is going to go out and do that inspection today. And he's got very defined criteria that says what a warning is, what an early warning is, and what an alarm is. And as you can see, that's really moving your P along the line. So when you get to an alarm state, your P is actually pretty far down the curve. But if you get to that warning or early warning state, your P is up the curve. So what you're going to do there maybe is you're going to increase your frequency where you're going to actually go out there more often because your potential failure is starting to occur, and um, that will then streamline the understanding of how long it's going to be until it really fails or functionally fails. So if technician one goes out there and it's at the early warning stage, he's looking for that less than one drip per minute. But if technician two goes out there, he now has the same, or she now has the same criteria that they're looking at the same thing. So they're actually, there's no misconception about early warning or alarm. It's really taking that knowledge base from your people that are 30, 20, 30-year employees that are going to be retiring soon, and getting that documented into the right strategy so that you're really all looking at the equipment the same way. So what do you need to do to run your reliability workshop? So we're going to talk about that in the next couple of slides. So the first thing you're going to do is, okay, I'm at the initial levels of my maturity. I got thousands of pieces of equipment. Where do I start? And you start with a criticality and risk assessment. So what that's going to do is it's going to help you identify what assets are that have the most relative risk or the most risk to the business. And that is key to really understanding. Although you might know that this asset is more critical, you might already be doing a maintenance program on that. So the relative risk of that is not as high as something that it might be low criticality, but it actually is eating your lunch every day because it's always constantly failing. So those are the things that when we do this prioritization analysis, we look at different elements. So we look at it from a health and safety perspective. We look at it from a environmental impact, a quality, a throughput, a customer service, operating cost, and a potential. And we take those and we look at the probability of that fail. And then from that, you look at the sum of the six elements and you multiply that by the probability of the failure, and that gives you your relative risk. And that's a starting point with your reliability program. So what do you need to get started? So now that you've done your criticality analysis, you know which pieces of equipment you're going to tackle first. But this is a this is a culture change here that you're doing. This is a whole different look from how you're maintaining your equipment, and this takes commitment, and it takes commitment from all levels of the organization. It takes commitment from resources, do you have enough resources to actually do this um, project or do this new program? And do you have enough people to actually execute this program when um, when you have all of these strategies built? There's a good chance if you're just in a break fix world that you may not have enough resources to actually execute the work. Um, so those are the key things that you got to think about and get commitment from your organization. Define the analysis boundaries. You want to define that boundary so that you're doing the analysis at the right level and the analysis is not too big or not too small. So if you look at, if we go back to that pump example, our boundary was those 3 pumps. Although there was the output of that was a whole other system where it pumped water to the town, it pumped water to the mine site, and then there was a whole other system before that where the all the water got brought in from the wells and the storage tanks and so forth. But we kept it within that boundary. Define your operating context. What is the asset? Understand that asset, the performance requirements, and so forth related to that asset. What are the key components, and what are the conditions that that asset's being operated at? Look at any current practices that are being done currently today. Although you are building a strategy from scratch, those practices will help you in defining your failure modes and help define your tasks that you're going to do. Any type of vendor manuals and so forth. And also your, as I talked about, resources and really committed those resources for the entire analysis. So that same team that starts the analysis needs to be with you till the end. And as I mentioned before, the presumption is that you're currently not doing anything as far as maintenance goes when you're doing those analysis. So what do you get from an output? So using a comprehensive maintenance strategy tool, you're going to get about 33% of failure modes that are going to be of some sort of a detective maintenance, where you're going to actually going to need to go in and whether it's some sort of failure finding, whether it's a an overhaul, or you're going to pull something apart to actually go in and look at it. 25% of those failure modes are going to be of some sort of a predictive maintenance. So whether it's vibration analysis, whether it's ultrasound, thermography, or even some sort of a visual, or using your 5 senses of your body, it really comes down to that um, aspect. And 5% of the failure modes are going to require preventive maintenance. So preventive maintenance is some sort of a scheduled restoration or discard task. And then surprisingly enough, 33% of those failure modes are going to be run to fail. When you start looking at the consequence of the failure and the worth doing exercise, um, it, it it just doesn't make sense to maintain. It's more costly to maintain than it is to let them run to fail. So so really, from an analysis output, you're going to get more detective tasks than predictive and preventive tasks combined, and it's surprising, but it's under when you base it on your consequence to the failure, the operating the consequences to the business, and the worth doing exercise, um, that is the output that you're going to get from your analysis. So now I'm going to turn things back over to Patrick, where he's going to talk about the leveraging of the library as an accelerator.
Thanks, Dan. Excuse me. Now that we understand the different types of programs, how to launch a reliability initiative, what are some key considerations when doing that, and what are your outputs? I'm going to show how you can use reliability strategies within MASS to facilitate this. So the reliability strategy library came out in version 8.11. And this was an IP acquisition IBM put through. So you immediately started with a new connection to 58,000 failure modes across 800 asset classes. And that included over 50,000 tasks for your job plans and your PM records to help develop those programs and include your mitigation activities. So on one side, you have a library that you're able to pull content into manage, which is a application or called an add-on. And it's essentially as easy as the assets application or straightforward. You're able to pull that content in, look at it, understand as you're running a program, which mitigation, and I'll kind of show you on the next screen what that looks like. So the idea here is you can leverage this library and application to help accelerate your launch of an initiative. Whether you do it in mass or you do it outside, we're here to show one of the configurations that we built. So this is a custom application in Manage to facilitate the workshop that Dan had mentioned earlier, right? You want to start with a risk and criticality assessment. And by doing this in MASS, we're trying to develop a single pane of glass so you can understand which are your most critical assets with the highest risk, and then document through the relational database which strategies have been applied to which assets, how those are developing, and what you're doing to monitor and maintain and then extend the life of that asset. On screen here, we can see we've got an assessment for 6 assets. And then the idea here is leveraging domains, right? We're able to set specific categories like safety, environmental, customer input, operating costs, throughput, etc., and setting those within the definition tab on the application for custom values for each one of those domains. This allows Dan and team to facilitate that workshop and document that directly into Maximo. Looking at the out-of-the-box library, we have a specific centrifugal pump that is oil lubed, and we're on the failure modes tab, right? So each one of the asset classes and configurations has a series of the boundary of the study on the overview tab, how the asset can fail, and then that includes mitigation activities. So working left to right, we're looking at an insufficient lubricant. This documents what the repair time is, what the functional failure is defined as, and the top 3 mitigation activities have the highest level of effectiveness. So through your study and workshops, you can pick which activity best suits your needs and then document that against the asset. Another option within that same application is you can copy or take what you find relevant for your program and then build a custom strategy. So the previous slide was an out-of-the-box strategy from that library. And here we've documented a custom strategy against the return pump, right? And within that, we can see and define the business drivers or the asset criticality and relative risk to the business. We can also define what the boundary study is. And then further, we can define what failure modes are most important. And I think this is the key component, right? We started to talk about is assets can fail in different ways. And then by documenting these based on the operating context and the functional failure, we're able to thread that together within Maximo and put our mitigation activities against each one of those. So, and following that thread, what can that look like? These are some additional configurations that we've put in. Working left to right, we have a dialog box that views associate strategies. So what strategies are we documenting against this specific asset? As mentioned, they can fail in different ways. So how are we tracking that? And what does that look like within the system? Coming over to the right one box, we have health scores attached to this. If you wanted to build those in, there'll be some functionality in 9.1 that will be extending health into manage, right? That should be considered. We're looking now at our PM and condition monitoring tab that's been added. So how do we visualize what records or what methods are we tracking those points of failures on risk-based inspections? As Dan mentioned earlier, are you looking at acoustics or thermography? Are you pulling data in from an external system like SCADA, a historian, etc.? We can build those measurement points within the application and assets, right? Tying to inspections or wherever else it is, and document that so that can trigger a technician to go out and look at it. In our primary tab on the assets application, we want to understand how critical this asset is to the business. We've documented that on the right. And if you need an in-depth view of that scoring, the last box here is our criticality tab. So again, there's different ways to do this. This is one perspective on how you can do that and keep it self-contained within Maximo. For our last poll, Elka is going to put this up here, and we are asking, how are you and your business tracking failure modes? So are they PCRs or problem cause remedies, work orders? Is there a work type designation for that investigation? Is it asset status or other? We'll give it just a minute here. Okay, as that's coming through, that should come up on screen here in a second. And I will turn it over to Dan for some key takeaways on what you need to know when launching a program and why or how some things might fail.
So if we talk about the different programs, 70% of RCM programs fail, and that's a known stat. And that was published by Reliability Web, but that's been a known stat for years. And some of the reasons why this is true is because of the as I talked about, the commitment from all levels of your organization. And this is a change management process. And by not implementing that change management piece of the project, it's really affecting the whole aspect of why you're doing this and why you're moving to this type of a maintenance strategy. Right from the technicians out on the floor doing the execution, to the operations team, understanding that, hey, I got to now take my equipment down for regular scheduled maintenance. What is this? We never done this in the past. So getting that whole aspect and understanding of why you're doing this. Um, another issue is not having the resources in place. So sure, you might have the resources to build that RCM program, but you don't have the resources in place to execute and make it sustainable. And you can have the best reliability program in place, but if you're not executing that work, really you haven't improved in any way. And then again, talking about maintenance and engineering and operations all being on the same page. So there has to be a buy-in from that aspect. And then the last one that is key is to get those efficiencies in place is you got to remove that non-value added work out of your maintenance system. So you have all that work in there, and now you're recreating some sort of zero-based maintenance strategy, maintenance program, but you don't remove the other work from triggering, or it doesn't get pulled out of the system. So you're actually still doing that same work plus all the new work, and it's just too much. So those are some of the watch outs that I've seen over the years, and it's very important to make your program successful. So we'll switch back over to Patrick for some final closing.
Thank you, everyone, for joining. I think we'll have a few minutes for Q&A, but wanted to say Cohesive is here to help. Whether you're looking to launch a reliability program, need understanding and how you're currently licensed and what that move to mass means, or understanding system performance, please scan the QR code or click the link in the chat and reach out. We can help. Turn it over to Elka.
Thank you guys for that informative session. So we have a little time left for Q&A. Dan, this is a question to you. It's a two-parter. So do you capture failure modes on VOs? Is the first part. And the second part of the question is, does Maximo have fields for capturing on VOs and storing a failure mode library?
So VO, I'm not sure I understand what that
Work
is.
orders.
Oh, work orders.
Mm.
So at this point in time, failure modes are not captured on work orders. Failure modes are captured on the asset using our customized application that Patrick displayed. But on out of the box, Maximo implementation just captures failure modes at the asset class and asset type level within the reliability strategies. If you implement what Cohesive has done by bringing it uh, down to the asset level, and we tie that back to the job plan and the PM, where you'll see the failure modes and the strategies there.
Great, thank you. And then if implementing reliability strategies, would I need to rebuild my hierarchy? Hierarchy?
So not necessarily, but you have to make sure that you're at the right level to build out your failure modes. So do you have to take it to every piece of a component? No, but you need to word your failure modes so that you understand which component you're talking about. And when you're building out those inspection tasks and meters and so forth, you have the right titles on those meters so that you understand where that failure could be occurring.
Okay, and then this is a follow-up question from the first question. If you aren't capturing failure modes on work orders, how do you measure your performance of your maintenance strategies?
So your your work order is going to be related to a specific task that you're doing, and then you're going to have failure codes that are going to be related back to the failure mode. So if you have your maintenance strategy where you define the tasks for that failure mode, then you're going to be doing the specific work related to the um, to that inspection task. For example, you have 4 or 5 meters related to the task that you're doing based on 3 or 4 failure modes related to that asset. So you're going to look at those meter inputs, and you're going to be tracking based on that. From a corrective perspective, you're going to have your failure mode, or sorry, your corrective tasks related to the indicator or meter that you're doing that inspection. So now we get to a warning or an alarm state. You're actually going to go out there and do some work on that. You're going to track that work order based on it originated from that condition-based monitoring point.
Okay, great. Thank you. And with that, we conclude our webinar. I want to thank you, our speakers, for joining us today, as well as our attendees for listening. And we have additional information available on our website in the form of blog posts, articles, case studies, and even brochures. If you want to reach out and discuss your strategic path forward, please do so via our website or where you can contact us with the contact us form. So that is a wrap for today's webinar. Patrick and Dan, thank you again, and I wish everyone a very great day.
Thank you.
Thank you.